Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to our video channel. Thanks so much for joining us for another video. And what we're going to be talking about in this video is the ability to optimize or cost optimize elastic block storage or EBS volumes inside of your Amazon Web Services account. There's a lot of different techniques that you can use to optimize storage inside of AWS. You might think that EBS is just kind of a really simple service. Just go create a virtual disk in EBS and you're good to go. But there's actually a lot to know about EBS, and the documentation for EBS is under the EC2 documentation. So EBS is kind of a child service of EC2 because they work very closely together. So be sure to reference the documentation for EBS anytime that you're trying to learn more about different volume types or more about the different IOPS that you can provision or things of that nature. So before we get into the video, I just wanted to briefly introduce StratusGrid. We are an AWS Premier consulting partner, and we're also an independent software vendor partner. And we have a software tool called Stratosphere, which if you go to stratusgrid.com, you can learn more about Stratosphere right up here. Essentially what it is it's a FinOps tool that allows you to find cost optimization recommendations across your entire AWS environment, and you can actually track the progress of your FinOps program as you start to make progress on implementing some of the different cost optimization recommendations. If you're interested in seeing a demo of Stratosphere, we would love to talk to you. So just go ahead and reach out to us directly, and we would love to set up a demo so you can see Stratosphere. So what we're going to be doing is actually jumping into the AWS Management Console here and taking a look at some of these different techniques that we can use to cost optimize. We'll also be referencing the AWS documentation for the EC2 service so that we can better understand how EBS works and some of the different information that's available on EBS volumes that we can use to make cost optimization decisions. Now, one of the first things that I wanted to suggest to you as an alternative to using EBS is actually to use something known as the local instance store volume. Now, what you might not know about EC2 is that certain instance types in EC2 actually have locally attached storage on the virtual machine itself. So when you spin up an EC2 instance, whatever physical machine in the AWS data centers that system is spun up on actually has some local storage available to it, again, depending on the instance type that you provision. So the easiest way to kind of figure out this information is to go out to the documentation for AWS here. So if we search for EC2 instance types and take a look at the different instance types that are available here, you can actually figure out which ones have local storage or not. So let's go over to the pricing page for EC2. And then if we take a look at on-demand pricing here, this will give us a breakdown of all the different types of EC2 instances that are available, and it'll show us in one of the columns whether or not we have local storage accessible. So down here under on-demand plans for EC2, we can choose an AWS region. I'm just going to use the default selected region right here, which is Ohio for now. And then down here, we actually have this huge table that has all of the different instance types that we can provision. It shows the base on-demand hourly rate. You can actually get a discount on top of that if you use spot instances, but we'll leave that topic for another video. But then what you can see right here is we have this storage column right here. And anytime that it says EBS only, that means that the only storage that you can use with that particular instance type is the network storage that's exposed from the Elastic Block Store service. If we scroll down and go through some of these different instance types, like let's actually do a search for C5AD, for example. So what you'll see with C5AD, for example, this D here indicates that it has local storage attached. So you can actually kind of break down this instance type here into a few different components. C5 is the instance family. There's actually newer generations like C6 and C7, but the C5 instance family is an older generation, but it has AMD processors. That's what the A here is. And then the D indicates that it has local storage attached. So there's other types of instances that have local storage as well. So if you search for things like AD, or if you search for ID, so the I indicates Intel processor instead of AMD processors. And then again, the D indicates that there's local storage. So you could search for those terms and kind of figure out which instance types you want to use. So if we search for AD right here, We actually have a bunch of different instance types, like M5 AD is another one. You can see that that has a single 75 gigabyte NVMe drive associated with it. This one right up here, this is an M6i actually. And so this has the D in the name as well, indicating that it has local storage. And this actually has four 1.4-ish terabyte NVMe local solid state drives. So one of the important things to understand about this locally attached what's called instance store volumes is that these are ephemeral volumes, which means that when you shut down your EC2 instance or you restart that EC2 instance, that's going to basically wipe all of the data off of these ephemeral volumes. There's no guarantee that the data that is stored on these ephemeral volumes is going to be long lived throughout the overall lifetime of the instance. So if you shut down that EC2 instance overnight and then the next morning you start that EC2 instance up again, all of the data that is on those local storage volumes is going to be completely wiped and you're going to be starting from scratch once again. So one of the things that you can do is to provision an EC2 instance with this local storage as long as the application that you're running on that EC2 instance is going to be able to deal with situations where that local storage gets wiped. So what you could have, for example, is some kind of storage caching server that is only using this local storage, this ephemeral storage on the instance store as kind of a local cache, rather than using it as long-term storage. That long-term storage could sit somewhere else, like S3, for example, or maybe EFS or other types of storage services that have persistence. But that's one option that you have is to actually, if you have a workload or an application that does not need persistent long-term storage, you can just leverage that instance store volume, and that way you don't have to pay an additional cost to attach a separate EBS volume to your EC2 instance just for that ephemeral data. So keep that in mind. Just make sure that you look up the instance type that you are provisioning, and it'll tell you what kind of local storage is available there. Also, if you go back to the AWS Management Console here, when you actually go out to launch an EC2 instance, you can select the instance type right here. Let's do a search for maybe C5AD once again, and we'll choose something like a C5AD large. And then if we scroll down in the launch wizard right here and go down to configure storage, you see this section down here that says instance store volumes. Well, there's a little link here that says show details. And if you click on that, you can see the details of the ephemeral volume that is available for the instance type that we just selected, the C5AD large. And as you can see, it's a 75 gigabyte volume here. So what you can do is you can spin up this instance, you can format that volume, and then you can point your application to the mount point for that volume, and you can use that as ephemeral storage. So just be aware that that is an option for certain instance types. And again, it's really dependent on what type of application you're running. But if that application needs just temporary storage, then that is a great option. All right, let's move on to another topic, which is going to be choosing the right type of EBS volume. When you create an EBS volume, and you can actually just create standalone volumes, you don't have to create an EC2 instance with a root or boot volume. You can actually just go directly out to the EBS service and hit create volume right here. One of the things you can choose here that's pretty important is the volume type. Now, the default volume type that you're typically going to see is either going to be GP2 or GP3 volumes. Those are what are called general purpose SSD volumes that allow you to run most types of workloads fairly inexpensively. However, there are other types of storage available. If you are looking for applications that are storing a lot of data that's not accessed very frequently, you can actually take advantage of the SC1 cold HDD storage tier here. And as you can see, we can have a minimum size of 125 gigabytes. So there is a minimum to be aware of there, and a maximum size of about 16 terabytes there. And this is going to generally be useful for applications that are not frequently accessing data. It definitely has lower throughput than other types of storage volumes. So if you're just kind of sticking some data onto that cold storage and not frequently accessing it, then this is actually a lower cost tier of storage than other EBS types. So let's go back over to this tab here, and let's take a look at EBS pricing instead of EC2 instance pricing. So now we're looking at the actual volume pricing for EBS volumes. And if you take a look at the cost for cold SC1 volumes down here, it's 1.5 cents per gigabyte per month. And again, you have to multiply that by the amount of gigabytes that you are provisioning. So the minimum is 125 gigabytes for those cold storage volumes. So the minimum price would be basically 1.5 cents times 125 gigabytes for the smallest size cold storage volume. So again, that's specific for applications that are storing long-term data that just doesn't need to be frequently accessed. But we also have the ability to use what's called throughput optimized hard drives. And this is ST1 volume types. And again, cold HDD and throughput optimized HDD are using traditional spindle-based disks. They're not SSD storage like what we have for the GP2, GP3, and IO1 and IO2 SSD volume types. So just be aware of that as you're thinking about the performance that your application needs. So as you can see, the throughput optimized here is quite a bit more expensive. It's 4.5 cents per gigabyte per month. So that's 3 times the price of the cold storage here. But with the benefit of the throughput optimized is that you're going to get a lot more throughput. Even though it's using traditional hard drives, you're still going to get a lot more throughput than what you get with the cold storage here. So just be aware of that as well. If you come over here to the creation wizard and you choose throughput optimized hard drives, you can see once again, we have the smallest size is 125 gigabytes here, all the way up to 16 terabytes. And this is going to give us a lot more throughput than what we would typically see on the cold storage here. So basically what it's saying is that a baseline number to evaluate your storage is that for every terabyte that you provision here, so if we say, let's do 1024 for 1 terabyte, you can see that your baseline throughput is going to be 40 and it can burst up to 250 megabytes per terabyte of provisioned storage here. So the amount of storage that you provision, if we go up to 2048, for example, that's actually going to affect the amount of throughput that you have by changing the size of the overall volume. Those are a couple of options that you have for colder storage and throughput optimized storage for hard drive based storage. But then we can actually jump up to the GP2. GP2 has more or less been replaced by GP3. So GP3 actually gives us a slightly lower cost. Rather than being 10 cents per gigabyte per month, you can actually get it for as little as 8 cents per gigabyte per month. So up to 20% discount there. But then one of the things you can do with GP3 is you can actually specify the number of IOs per second, IOPS, that you want for that particular volume. And then you can also change the amount of throughput. So throughput is like your bandwidth, that's the size of your pipe. And then the IOPS is the number of operations every second that can be performed. So an IO could be something like 2 kilobyte text file that you create, or an IO can actually be represented all the way up to, I think it's 16 kilobytes per second. If you take a look at the EBS documentation for the IOs per second, they actually talk about what the different IO sizes are right here. So let's go ahead and take a look at the SSD volumes right here. And if you take a look at EBS general purpose and take a look at GP2 and GP3, the IOs per second are going to be based on 16 kilobyte individual IOs for GP2. But if you use GP3 storage, each IO is actually 64 kilobytes here. And then the maximum throughput for GP2 is a lot less than the maximum throughput for GP3. But if you do increase the throughput or the IOs per second, you do pay an additional price for that additional capacity. So you want to make sure that when you are provisioning these different types of volumes, for GP2, it's just a fixed cost. But with GP3 volumes, you do have the ability to increase your provisioned IOPS or your provisioned throughput as well. And the same thing applies for the IO2 volume type down here. IO2 is what they call block express storage. And so this is for really high throughput applications like database servers or anything that's reading and writing lots and lots of data to a storage volume. And this is going to cost a fair bit more for the base storage, but then on top of the actual base storage, you also are paying for the IOs per second here. You can see they kind of have this tier-based system here where for the first 32,000 IOPS, you pay one rate. If you go above 32,000 IOPS, you pay a slightly lower rate for the next tier. And then if you go above 64,000 IOPS, then you're paying an even lower price per IOP. But that starts to get really expensive, and it's generally reserved for applications that have really, really high throughput needs. If you have a database server that's maybe 5 terabytes in size, and there's just lots of different application servers that are all hitting that database at the same time, it might be appropriate for that given workload to use this type of storage. We're actually going to take a look at some metrics for EBS storage to better understand the actual utilized capacity of an EBS volume versus what it is provisioned with. With IO1, this is kind of the previous version of the IO2 volume type up here. So IO2 may not be available everywhere yet. I'm not quite sure where they're at with that rollout, but IO1 is the previous generation of the provisioned throughput that's based on SSDs. And again, you pay per gigabyte of storage per month, and you also pay for the IOs that you provision. So if you go back to the wizard here and you select GP2, all you have to do is specify the volume size, like 1024, that's a 1 terabyte volume, and the number of IOs per second that you get is based upon the size of the volume. If we say it's 512, then we have a different number of IOPS here. If we say it's 2 terabytes, then we get a different number of IOPS. So there's a direct correlation between the size of the volume and the IOPS. With GP3, it's a little bit different because we have the option to increase our IOPS beyond the baseline. We also have the ability to increase our throughput beyond the baseline as well. So if we go down to 1024, a 1 terabyte volume here, we still have a bare minimum of 3,000 IOPS, and we have a minimum of 125 megabytes per second of throughput. If we bump it up to, let's say, 4,096, a 4 terabyte volume, we still have the baseline IOPS and throughput, but we always have the ability to increase this. So if we specifically need to go up to 4,000 IOPS, we can specify that here. We just have to take into account the pricing that is specified right over here. So for each of those additional 1,000 IOPS beyond 3,000. So if we go from 3,000, that's included, and we go up to 4,000, now we have to pay for 1,000 IOPS above the baseline of 3,000, and those are half a cent per month. So we would have to basically pay 500 cents, which is $5, for the additional 1,000 IOPS that we're provisioning if we were to change this to 4,000 IOPS. Plus we pay for the storage, plus throughput. Throughput includes the baseline for free in the 8 cents per month here per gigabyte. And if we go above 125 megabytes per second, like if we go up to, let's say, 200 megabytes per second, then we are going to be paying additional per megabyte per month above and beyond 125. So if we go up from 125 to 200, now we have to pay additional for that 75 megabyte per month throughput per second. And then that's going to be 4 cents. So 4 cents times 75 additional megabytes per second of throughput, that's going to be essentially, I think, $3, if I'm doing my math correctly, that we would be paying for the additional throughput to go from 125 megabytes per second up to 200. So there's a lot of customizability here. Again, if we go to the IO1, we can specify the IOPS here. If we go to IO2, we again can specify IOPS here. IO2 gives you quite a bit of flexibility. The minimum is 100 IOPS per second. Maximum is 256,000 IOPS per second. And again, if we go back to the EBS volume types documentation right here, you can see that for provisioned IOPS volumes, we have IO1, IO2 Block Express. And each of those is going to offer a maximum of 64,000 IOPS, each IOP being 16 kilobytes in size for IO1. And then for IO2 Block Express, it's also 16 kilobyte IOs individually, and you can have up to 256,000. So if you have a really large application that needs tons and tons of read-write IOs per second, the IO2 Block Express is going to give you the maximum flexibility at the top end of the block storage performance in EBS. Of course, you're going to pay for it as well, but that gives you the most flexibility from a performance perspective. So what we can do is go ahead and actually create a volume here. So what I'm going to do is just create a basic GP2 volume for the time being. And I'll just create, let's say, a 20 gigabyte volume. That's going to give me a baseline of 100 IOPS here per second up to a burst capacity of 3,000 IOPS per second. You can also create an EBS volume from a specific snapshot, but I'm just going to create an empty volume for now. And I'll just add a tag here that says owner, Trevor Sullivan, so my teammates know that I own that volume. And we'll click on create volume. Now, one of the cool things about EBS volumes is that they actually include per minute or 1 minute metrics for no added cost. So EBS just includes that. If we do a search for EBS metrics in CloudWatch right here, check out this documentation page right here. We can see that data is available automatically in 1 minute periods at no charge. And then there are a whole bunch of metrics that we can use to determine how much of the capacity of that EBS volume is being utilized. So if we take a look at the metrics for EBS volumes, we have things like volume write-ups. So this is how many operations are being used to write to that volume within a specified period of time right here. We also have volume read ops here to see how many IOs are being used for reading here. And then we can also see the bandwidth or the throughput of the volume as well. So we can see volume throughput percentage, and this only applies to provisioned IOPS. We also have a couple of other options here to see the volume read bytes and volume write bytes, and we can use that metric to determine how much data is being read from the volume. So that's how much bandwidth essentially is being used and how much data is being written to a volume as well. And that will help us to evaluate what the appropriate size of our volume should be, not from a capacity perspective, not from a storage capacity perspective, but from an IOs per second and a throughput or bandwidth perspective. That'll help us to appropriately size our volume. There's also some related metrics here that are available on the actual EC2 instance itself that help you to understand how the EBS volumes are being used, but we're just going to focus on the actual volume specific metrics for now. And now that we've provisioned an EBS volume that is empty right here, let's go ahead and just refresh the view. You can see I've got this new volume right here that is 50 gigabytes. It's got up to a burst capacity of 3000 IOPS. It's got a throughput of 125 megabytes per second right here. Actually, I'm going to delete that because I think this is the one that I just created. So it's 20 gigabytes. 100 IOPS is baseline and has a burst capacity of 3000. And then the throughput is undefined because the throughput is just based upon the GP2 volume type right here. So what we're going to do is actually go over to CloudWatch, and I want to take note of this volume ID right here. So it's 0BBA. We can navigate over to the CloudWatch console right here, and we're going to actually take a look at how to search for that specific volume in the metrics. So if we go to CloudWatch metrics, what we can do is come down here to search for any metric. We also have these different namespaces right here. And you can see right here, we actually have the EBS metric. So we'll go into EBS, we'll go into per volume metrics so that we can find metrics for a specific volume ID. And then what we can do is find the volume ID that we had provisioned. We could always go back and find that, or I'll just kind of look through this list right here. I think we actually had another page right here. So let's go to page number 2. And we are looking for the one starting with, I think it's 0BBA. Let's actually just open up another tab here in EC2 and just double check that. Go down to volumes. And yeah, it's vol-0BBA. And what I can actually do is just click on the volume and then in the details, click on the copy icon there to copy the volume ID. And then if we go back to the CloudWatch console right here, we can just paste in that volume ID right here, and that'll allow us to see all of the metrics related to that volume. Now, as you can see, we don't currently have any metrics for that volume. It's not currently actively being utilized at all. So if we don't have any metric data here, we can go ahead and actually spin up an EC2 instance with a volume attached and actually consume some capacity on that volume. So what we'll do is head over to the EC2 console. We can go to instances right here, and let's just launch a really basic instance. I'll just call this EBS test Trevor, and then we'll use an Ubuntu image here. For the instance type, we'll just choose something like a T4G, and let's actually change the architecture to ARM here. and say confirm. And then once we confirm that change, we can choose something like a T4G small, and I'll choose an SSH key pair here, plug in some VPC details so that I can connect to that EC2 instance. Just choose one of my public subnets right here, choose a security group so that I can SSH into it. And then I'll just give it the default root volume here. So this is going to create a new EBS root volume for the operating system. And then for the instance profile, I'll just choose one of my built-in IAM roles. You don't have to choose that, but I'm going to for this particular instance. And then under the spot options down here, we're going to choose spot instance. And then I'm just going to specify that the request is a one-time request. And we'll go ahead and say launch instance. Now, once this instance is launched, we can actually attach the 20 gigabyte volume that we just created to this instance, and then we can actually utilize that volume on the instance itself. So what we'll do is go ahead and SSH into this instance right here. So let's open up a new terminal. We'll say SSH Ubuntu at this IP address right here. And then once we get SSH'd into it, we'll be able to go ahead and attach that volume. It looks like I assigned the wrong SSH key to that. So what I can do is just come in here to connect, and then we'll use EC2 Session Manager or Systems Manager Session Manager in order to connect to this instance from our web browser. So let's click on the connect button right here, and that should take us straight into a terminal on this EC2 instance. Perfect. And then now what we're going to do is just run a bash shell right here, and then I'll go ahead and su Ubuntu right here. And let's actually see, who am I? I'm the SSM user here. So what we'll do is go ahead and just attach this EBS volume. Let's go back to our AWS Management Console right here, go to our instance, and then we're going to right click on it. And we are going to go ahead and say that we want to attach that volume. So we'll actually do that under the volume itself in this case. So what we're going to do is find our 20 gigabyte volume, and then we're going to say actions and then attach volume. Then we're going to select which EC2 instance we want to attach it to, which is going to be this one right here that's currently running. And then we can give it a device name like /dev/SDB. And then we can go ahead and attach that volume to that instance. Now it looks like that attachment point is already used, so we're just going to choose a different one like /dev/SDC instead. Looks like that one is used as well, and it looks like we might actually need to use the XVDBC naming convention here. So let's go ahead and try using XVDF down here and say attach volume. And then you can see that that volume has now been attached. If we go back to instances, go to the storage tab, you should now see, if we refresh the view right here, that we have a second volume. Now it's attached to /dev/xvdbf, and it's 20 gigabytes in size. So now we have the root volume, which is the operating system volume, and we also have the additional 20 gigabyte data volume attached right there. And so now if we go back to the CloudWatch service right here, let's open up a new tab with the CloudWatch console right here. And then what we're going to do is take a look at the metrics for these volume IDs. For starters, let's look at the OS disk, which is the 8 gigabyte volume right here. And if we go down to all metrics and then search for EBS for volume metrics, we can go ahead and just paste in the volume ID right here. And now you can see all of these metrics related to this volume. So we can see how many bytes are being read and written. Let's change the time frame to 1 hour right here. We have volume write bytes. We have volume read bytes here as well. We have a percentage of volume idle time that we could use as well as a metric to help determine how much the volume itself is being used. So there are a lot of different metrics here that we can take a look at to determine the utilization of a volume. It does take a little bit of time for these metrics to start showing up in CloudWatch, so just be patient. You can also go ahead and just change to a custom time frame here, so something like 15 minutes, for example. And at this more granular level, you can actually see these per minute metrics showing up right here. So we're starting to get some data points. You can see that the volume idle time right here, if we hover over it, is currently at 56%. So it's 56% idle and 45 or 44% in use. And then you can see volume read bytes is 65 megabytes and volume write bytes is 45 megabytes in that time frame. So these are very useful metrics that we can use to determine the overall utilization of that volume. If you click on graphed metrics right here, you can change the period for all of these metrics down to as little as 1 minute here. And so now you can actually start to see these lines at the initial boot time. We started to have a little bit of volume utilization right here, but then over the next several minutes, the utilization of that volume leveled off. And so now our idle time is going to be up closer to 60. And the volume write bytes here is much smaller. The volume read bytes is much smaller as well. And so this is going to give you an understanding of how much that volume is actually in use. So lots of useful metrics there. Again, on the data volume as well. So let's go back to our EC2 instance here. Let's grab this volume ID for the 20 gig data volume. And if we come back to browse metrics right here and search for this volume ID as well, let's get rid of this first one here. Now you can see we've got the same metrics here as we had for the operating system volume. So we've got volume idle time. This is actually idle time, not idle percentage. So at a full idle, you're going to see 60 seconds per minute right here. So you can see that that red item right there is the data volume. It's completely idle. It has absolutely no operations, read or write happening to it. So it is at the full number 60 there. And so the idle time here on the other volume is actually indicating it's 59.99 seconds idle, and there's just a very minimal time where it's actually being in use. So that's actually a idle time, not idle percentage, just so you're aware of that. Okay, so those are some useful metrics that we can use to determine the utilization of the volume. And then based upon the actual IOs, so if we take a look at one of these volumes that has like write operations and read operations here, what we can see is that our read and write operations are 0 right down here, right? So for 0 BBA, the read and write operations are 0. So the indication here is that we do not have a lot of activity. And so if this was a provisioned throughput volume, we could actually go into that volume and resize it to the appropriate size. So if this 20 gigabyte data volume here was not appropriately sized, we could go to actions and then say modify volume, and we could change the parameters of it to be more appropriate. So if it was IO2, we could say, hey, this should be something like, 100 IOPS, which is the smallest. And then we could say modify volume. And you can only do one modification operation every 6 hours. So just be aware of that. You can't just change it back and forth very frequently. But this allows us to kind of appropriately size these EBS volumes according to our specific needs. The other thing that you can do to cost optimize your EBS volumes, in addition to appropriately sizing them based on your CloudWatch metrics, is to find volumes that are not actively in use. If you go into the EBS console here and you take a look at the status right here, the volume state, you can see that currently this one is in use and optimizing, and it's optimizing because we just made a change to the volume configuration. But if we take a look at another volume, you can see it's just normally going to be in use. And so if you scroll over a little bit here, there's actually a column called volume state. If that column isn't showing up for some reason, just click on the gear icon right here, and you can activate the volume state column right here or disable it depending on your preferences. But what we want to do is we want to look for volumes that are not actively in use, and we want to find volumes that are provisioned and are just detached from any EC2 instance. So for this volume right here, we could potentially detach that volume from our EC2 instance, and the volume will still exist inside of our AWS account, and we're still paying for that capacity, but that volume is no longer going to be attached to that instance, and so it's not going to really have any value to us as a provisioned volume because there's no applications that are able to actually access this data. So now if we refresh the view, you can see that the volume state has changed from in use to available. So what we can do is just look through our list of EBS volumes here and see this one that says available instead of in use. And that is a potential candidate to delete. So we could just say actions, delete volume, and then we could say delete right here. And then that will allow us to delete that volume. Another option that you have, if that potentially contains sensitive data, so let's say maybe it had a name tag on it that says important database, so that's kind of an indication to us that there's something important there. We could also take a look at the other tags to see if there's any other useful metadata that's been describing the purpose of that volume. Then what we could do is actually take a snapshot of this volume first. So if you right click on it and say create snapshot, we could give this a snapshot and say 2024-11 and say important DB database snapshot. And then once we take a snapshot of that EBS volume, then we can go ahead and safely delete it. And that way we have a backup just in case we need to restore any of that data. So let's do actions, delete volume, and we'll say delete right here. And so now that we have a snapshot of that volume, we have safely deleted it. You can see it's now in the deleting state. And after just a few moments, that volume will eventually disappear from our account and will no longer be billed for that storage capacity in EBS. So we'll just go ahead and let that delete, but now we have a snapshot. So let's switch over and talk about snapshot optimization. So if we click on EBS snapshots down here in the corner, the other thing that we can do with EBS snapshots is to look for old snapshots that are no longer needed. If we have really old backups that are maybe 5 years old or 4 years old, or maybe even 2 years old, if we have a policy in our company that says we don't really need any backups that are more than 2 years old, then what we can do is come into the snapshots right here. We can take a look at snapshots that are owned by me. That's basically owned by the AWS account that we are currently logged in with here. And then you can see that we have this snapshot. It's 20 gigabytes and it has the description that we just gave it right here. So what we can do is say, you know what? I'm going to take a look at the tags on this snapshot, and maybe somebody added a tag that says valid until, and maybe they said it's valid until 2026-11, right? So anytime after 2026-11, this backup or this snapshot is no longer required. So if you have a good tagging strategy that has kind of these future expiration dates associated with all of your snapshots, this really helps us to easily identify which snapshots aren't actually needed. If you don't have that tagging metadata though, you can just go to the details and you can see when that snapshot was initially created. So it's called started. That just means that that's when the snapshot was initially created. And so you can see the exact date and timestamp when that snapshot was created. So if we jump forward 2 years to 2026, we look at this start time here, or we take a look at these tags that hopefully our teammates added to these resources, we can say, all right, this is no longer needed. So we'll just go ahead and say actions and delete snapshot, and we can just say delete and get rid of that snapshot there. So now that snapshot is no longer being charged to our account because there is a cost for taking snapshots of EBS volumes. It doesn't cost as much as the EBS volume itself, but there is still a cost to store snapshots. So you want to make sure that you're periodically going in there or have some kind of automated process that can go in and clean up those snapshots as necessary. So those are a few different techniques that we can use to go ahead and optimize our environment. We took a look at things like the ephemeral storage. We took a look at the different volume types that are available for EBS. We took a look at things like how to identify EBS volumes that are detached from any EC2 instances and are just sitting in the available state. We took a look at things like GP2 to GP3 and how those are cost different and performance different from each other. And we also took a look at the provisioned IOPS modes and how those are good for really high level workloads. But if we are not actually utilizing all that capacity, we can take a look at those CloudWatch metrics to help us figure out how to appropriately size the IOPS and the throughput configurations for those IO2 block express volumes. So make sure that you take advantage of the CloudWatch metrics that are available here and make sure that you understand what those metrics actually mean. If you click on this little info here, you can actually get a description of that metric, and then make sure that you're looking at these metrics to understand how that EBS volume is being utilized and whether it's a candidate for being cleaned up or if it's just a candidate for potential reconfiguration to optimize the size and throughput of that volume. So anyways, thanks so much for joining us for this video on EBS volumes. I hope that you learned something new. Please leave a like, subscribe to our channel, leave a comment down below, and let us know what you learned from this video. Thanks so much, and we'll see you in the next video. Take care.